Good morning, class. Week 5 of Integrated 3, Quarter 4 means Assignment 5 of Week 3, Quarter 4. This one is on inferences about a population, as is the case with the rest of these assignments for the rest of the year. These are fun little review assignments from Integrated 2 or just from other concepts I put together to help you not only review things you might have forgotten over the years, but get some rare application of math that might, in fact, be very useful to you out in the quote unquote real world when you graduate and leave my class. All right, so we're going to dive right into it. You're going to look and see very similar problems on your own assignments. And so follow along. The numbers will be different, but the patterns will be very similar. This is going to be kind of like a slam dunk, just going over vocabulary together and filling it out. And you'll notice some of these problems, like this first one, they've got this little weird, they have like two A's that are just sort of there. I think there's some older problems I need to potentially fix. All right, but starting with number 1. It says, Tammy asked a random group of 100 dog owners in her neighborhood if they used the dog park with their pets. Of those asked, 5 had taken their pets to the dog park in the last week. Tammy inferred that most owners in her neighborhood do not use the dog park. Choose each inference that correctly describes the strength of this inference. Okay, so first of all, inferences of a population. In general, this is pretty applicable in the world. If you can be very confident one way or another about something, like I am very confident that I love chocolate, but I'm also very confident that I dislike eating sardines. Those are both strong inferences. If I asked people around the school how many people prefer sardine pizza, and only 2 out of 200 people said that they did, that's also a strong inference because it's really obvious that no one likes sardines. A weak inference comes in a couple ways. One is if it's really close to half. So if I ask people, here's a popular one, do you prefer chocolate candy or do you prefer non-chocolate candy like Sweet Tarts and Skittles, Starbursts, cotton candy? A lot of people will choose chocolate, and a lot of other people will choose the other kind of candy. So it might be like 60-40 chocolate or something, but that's still weak because it's close to half. So we're going to look through each of these problems and see, first of all, is our percentage really high or low? Obvious, one way or another. That's going to be a strong inference. And then the other thing is sample size. So if I had 1,000 people who went to my school, I'd always want to make sure that I asked 20% of them. You could find that by dividing by 5. If I asked at least 20%, then my sample size would be large enough to make a prediction. If I didn't, if I asked, 3 total, that wouldn't be accurate enough to guess what the whole 1,000 people thought about my question. So we're going to be looking for that. But this first problem, we only have 100 dog owners. They don't tell us how many people live in the whole town, so we don't have to worry about that. Instead, we just know that this extremely low amount, or 5% of dog owners, use the park. Well, 5% is really small, and it's really obvious that they don't use this park. So it's a strong inference. That's this third one for me, because it's really low. Now, some of you guys might have a really high number here, like 95%. That's also a strong inference because it's not close to half. And look what it says when you get it right. You deserve a Scooby snack. You'll notice the other ones are not true. It's not weak, because as I said, it's a strong inference. And it says it's impossible to determine the strength of the inference. No, we know, again, it's a strong inference, because it's really obvious one way or another. And immediately we get a second example, a very similar problem, where out of 120 dog owners, only 72 had taken their pets to the dog park last week. And that ends up being a number close to half, 60%. So the other one was really low or high. This one's close to half. If it's close to half, you know that it's weak because of that percentage. Now, it was not biased. She did not just ask people who, for instance, own dogs, whether they use the park. The sample size, we could do, if we did 72 out of 120. And then that's 0.6. And if we wanted to know what that was as a percent, we could multiply by 100. That's where you got 60%. And if we had a total amount of population, we could do the same thing to see sample size. But because, again, we don't know how many people live in the town, it's just our one answer. We cannot talk about sample size. All right. Yay. Next. Jeremy asked a random group of 40 students at his school if they use mechanical pencils. There are 1,250 students at his school. Of those asked, 18 said they used mechanical pencils. Jeremy inferred that most students use mechanical pencils. Choose each statement that correctly identifies the strength of his inference. So first of all, let's look, because we do have now 1,250 total students, and we're only going to ask 40 of them. So we are able to calculate sample size. And again, I could just multiply this by 100. That's 3.2%. Ooh, that's bad. We need at least 20%. So we know our sample size is small. So it's weak because the sample size is small. We also know that it's 45%, and that is one of these that's close to half. Now, you could never have an inference be strong and weak simultaneously in these problems. And so it's just going to be weak for two different reasons. The percent and the sample size. Now, these might be in different orders for you, so make sure that you match it up correctly. But those are going to be your two kind of answers. And look what it says. Sharp answer, like a mechanical pencil. Oh, I love puns that are so bad they have to explain it. All right, number 4. 101 out of 419 7th grade boys were surveyed regarding their hair color. Choose each statement below that's supported by the data. So again, we have brown, black, blonde, and red. 101 total out of 419, so I can check. 101 out of 419. Is that at least 20%? Times 100. Yeah, 24%. So our sample size is large enough. So ignore the total as far as the hair colors. Just looking at brown, black, blonde, and red. Do we have a number that's either way larger or way smaller than the rest that we could be confident that the whole school would have a similar pattern? In this case, yes. Black hair is not only much larger than brown, blonde, and red, but red hair is much smaller than the rest. And that's true to form, at least with red hair. Red hair is pretty rare. If you have red hair out there, congratulations. You're one of the unique few. So we have two strong inferences. We could strongly infer that around the school, the fewest boys would have red hair, and the most boys would have black hair. Awesome. Good answer. I might add, apparently, it was a good answer. Or is a sharp answer like a sharp cut? Or a cut above, like a good haircut? Which, if you're like me, you just had your haircut by your wife during this quarantine, it's really tough to find a good haircut now. All right, number 5. 142 7th grade girls were asked, what is your favorite sport to play? There are a total of 368 7th grade girls at the school. Okay, so 142 out of 368. Let's check that right off the bat. Is that at least 20%? Yep, 38.5%, so sample size is good. Now let's look, is there a sport that's way smaller or way larger than the rest? Well, we have one that's the smallest, volleyball. We have one that's the largest, basketball, but not by a lot. Like that mark of 3 between soccer and basketball, or that mark of 1 between volleyball and softball, that could easily be made up by the rest of these girls at the school. I don't know from this data that for sure volleyball is the least popular or for sure basketball is the most popular. So now I cannot make any strong inference about this. Therefore, any inference is weak. It's not because of the sample size, we check that, and it's not because of something that's going to happen in the future. I have no idea what's going to happen in the future. Volleyball might cease to exist in 10 years for all I know. Who knows? All I know is that right now, at this exact moment, that any inference is weak because no sport was clearly most or least popular. All right. Swish! That's for basketball. You guys might get your own sports-themed pun here. I have seen a variety of responses over the years. All right, the next one, we have 79 out of 212. 79 out of 212. Again, we're checking for just 20%. And I'm not even going to multiply by 100. You can see the pattern now. Ends up being 37.2% over 20. And look at soccer sticking up like a sore thumb. So volleyball and softball are getting really close together, just 2 apart. That could be easily made up from the rest of the students. But soccer being 29 greater than basketball, that is such a large amount that I'm going to assume from this data that it is going to be a trend for the whole school, and that we know, not that it's going to remain the most popular, again, we can't predict the future, but I could strongly infer that right now, at this moment in time, the most popular sport to play among 7th grade girls is soccer. Again, yours might be a different sport, different setup, but it's going to be a similar kind of thing. And I got Swish again. What did you guess? A lot of times you'll get different ones, so it's kind of rare that I got the same one twice in a row. All right, look at this one. Boom. Volleyball sticks out as the lowest. Everything else is tied. So all I know, again, nothing about the future, is I can be strongly infer that the least popular sport to play among 7th grade girls is volleyball. I personally love volleyball. I'm really bummed that the student staff volleyball game had to be canceled due to this outbreak. I look forward to playing that someday. Slam dunk! I've gotten all basketball-themed ones. Again, that's not guaranteed. Interesting. And finally, below is a sample of 286 students at Capital Elementary School, and 72 of them ask, out of these choices, they answer what president they think is the most popular. This is a little dated, by the way. You can see these presidents that are listed. And you'll notice that they're all about the same. So we're going to check our 72 out of 286. Is that at least 20%? Yeah, 25%. And even though Obama and Washington are the highest and Reagan, Kennedy are the lowest, they're all still about the same. There's a lot of students left that haven't been counted. They could easily make up the ground, and any one of these presidents could end up becoming the most popular by the end of the survey. So any inference is weak right now, because no president is clearly the most or least respected or popular. And this might be my favorite pun of them all. Look what it says when you get it right. You could be the president of Mathland. Oh, that is so silly. I am noticing as I'm going over this that you get the points, but this is one of those old school ones that I hadn't checked the setting yet and changed them to all be green check marks that light up when you're done. So I'm going to go and do that after I submit this video. So that should be done by the time that you follow along with this video in the future. For now, though, take my word on it I'll hit submit it all and finish. You can see that I get that beautiful 100. And there are the green check marks all filled out. All right, I'm going to go adjust that setting. In the meantime, I wish you the best of luck with this assignment. Hopefully this made sense and was very helpful. As always, this is an example of class away from class, and I hope this video finds you safe, happy, and well as healthy out there. Take care, and best wishes with your week.